41601, tetrahedral precession of closest packed spheres. A. So we're starting here, the drawing A. Two pairs of 7-ball triangular sets of closest packed spheres precess in 60-degree twist to associate as the cube. This 14-sphere cube is the minimum structural cube which may be produced by closest packed spheres. 8 spheres will not close pack as a cube and are utterly unstable. First of all, let's start at the end. 8 spheres. You take 4 balls and 4 balls, and that would form a cube, right? Because there's 4 on each side, and it would form like a die or a cube. That is not close packing because the spheres are not close packed. They are one on top of the other. When you close pack, they get offset and they sit in their nests. They sit in between one another. So this is the minimum, and it's 14. And 14 is an important number. It's going to show up in our reading later, referring to carbon-14. B. When 2 sets of 2 tangent balls are self-interprecessed into closest packing, a half-circle interrotation effect occurs. The resulting figure is the tetrahedron. I understand most of that, and this is a beautiful thing. So got 2 balls. I can certainly picture this, and then they will precess. They will force each other to turn so that they can fit in closest packing, and they will describe tetrahedron. A half circle of interrotation effect occurs. And letter C. The 2-frequency, 3-sphere to an edge, square-centered tetrahedron may also be formed through 1/4 circle precessional action. There's 3 spheres to an edge, which is 2-frequency. It's got 3 spheres on the side. And notice how it's colored. It's composed, in this case, of 3 in a row and 3 in a row that's settled into a base, a square base. And I would call that a 90-degree rotation, which Bucky called it a 1/4 circle.
Yeah, about that A diagram that's also known as a Merkaba or Merkaba.
Yes, the Merkaba is a colloquial name for 2 nested tetrahedra that form a cube in their outline. So these are different drawings of the Merkaba.
And it's interesting that it's 2 interpenetrating tetrahedron, because my other comment would be that close cubic packing is like the scientific term for it, which always bugged me because I come from Bucky's world where there's like this deep resentment against everything being cubic, and then we get into this beautiful triangular grid and they call it close cubic packing. But it was explained to me that it has to do with how there's actually 2 cubic lattices that are interpenetrating. That third one over, the kind of, that yellowish one, you can see there's a second cubic grid that's beginning there in that second. It says body-centered cubic, right? Yeah. So that's the corner of another cubic lattice, and they're interpenetrating, so you can conceive of it that way. And then when you put it all together, then you have a triangular grid. But I do think that it's easier to comprehend the thing when you think of it as 2 interpenetrating cubic lattices. And it's sort of a fractal pattern that emerges that way because the nucleus inside of that cube implies another cubic lattice, but it has all kinds of missing points that wouldn't be represented by spheres.